All right, in this video, we're going to take a look at reflections across the x and y axes of the graph of a function. So for the function f of x is the square root of x, determine the effects on the graph if we have g of x is negative f of x. So if we have something like negative square root of x. Well, once again, in red, we have our square root of x function. It's called our parent function. And then g of x is going to be negative f of x, or negative the square root of x, where the negative sign is outside of the function. So here is the graph in blue of g of x is negative f of x. So here's f of x equals the square root of x, and in blue we have g of x is negative square root of x. So as we can see, the original function was reflected across the x-axis, and that's going to happen when you multiply your entire function by a negative, in this case negative 1. All right, now let's see what happens if we multiply our input values by a negative. So we're just going to uncheck this, and we're going to move this negative inside the function. So outside the function reflected across the x-axis. So I'm going to pause the video and see if you can deduce what is going to happen if we multiply the inside of the function by a negative. And all right, so let's see if you're right. So graphing g of x, and it reflected it across the y-axis. So now all of our x-coordinates become their opposites. So when it was outside, the y-coordinates became their opposites. When it's inside, the x-coordinates become their opposites. So this time it reflects across the y-axis. All right, example 3, determine the effect on the graph of f of x is the square root of x for each of the following. So we have g of x is negative square root of x, and then plus 2 outside the function. So a little bit of review from the last video. So let's take a look at, let's delete this, and we have negative square root of x. I'm just going to uncheck this for a second, and then plus 2. Well, matter of fact, let's see what happens first with the negative square root of x. That should reflect it over the x-axis. And then taking that result with a plus 2, as we saw in the last video, that's going to move all those points up 2 units, giving us this graph in blue. So with the negative square root of x plus 2, we have the negative outside the square root as a reflection across the x-axis. And then we're going to shift it up 2 units because we're adding 2 outside of the function. All right, part B, we have g of x is square root of negative x and then minus 3 outside. So we can start with, let's clear this out. All right, so again, f of x is the square root of x, that's in red. Putting the negative inside this time, just like we saw before, is a reflection across the y-axis. And then the minus 3 afterwards is going to shift everything down 3 units. So it took all those points and moved them down 3 units, just subtracted 3 from all the y-coordinates. So in this one, we first reflect across the y-axis with the negative inside the square root, and then we shift everything down 3 units. So I strongly encourage you to use technology to graph as much as you possibly can. All right, finally, part C, we have g of x is 4 minus the square root of x. And we're just going to rearrange these. So instead of 4 minus the square root of x, it looks a little bit more like example 3a. And we'll write it as negative square root of x plus 4. So now it looks almost similar to, very similar actually, almost identical to example 3a. But, if you want to know where the stuff comes from for all these slides, that was a sneak peek. A lot of work, but it's worth it. Negative square root of x, so it flips it over the x-axis, and then plus 4. So our first item of business is reflect across the x-axis. It's because of this negative sign out in front. And then the plus 4 outside of the function means we shift it up 4 units. All right, that about does it for this video. Thanks for watching, and I'll see you next time.